Hello everyone, welcome to Network Jungles. Today we talk about subnetting. Subnetting is the important topic in the network field. So, most of the into time or working time, we need to know the one of the topic is subnetting. Let's see what is subnetting. So, subnetting is the process of dividing a network into a multiple smaller network. So, it will reduce the wastage of IP address and smaller broadcast address, then minimize the network traffic, and it can improve the security and performance also. Then, subnetting can be classified into two main categories. One is FLSM and another one is the VLSM. So, FLSM is the fixed length subnet masking. So, based on the name, the subnet masking value is fixed. And VLSM. VLSM is the variable length subnet masking. So, based on the name, the subnet mask can be varied based on the requirement. Next one is the private IPv4. So, it is already discussed in my second video part. Once again for subnetting purpose also. So, private IP can be provided by the network admin, which is managed by internally, that is the inside of organization. It is also called LAN network, that is the local area network. So, private IP can be classified into three classes: Class A, Class B, Class C. So, Class A is the range 10.0.0.0/8, that is the subnet is 8. Then, Class B. It is the 172.16.0.0.2, 172.31.255.255. It is the /16 subnet. So subnet is the important for the every classes. Then next one is the class C. 192.168.0.02, 192.168.255.255. It is the /16 subnet. 127.0.0.0. It is used for loopback address. So next I talk about the every classes subnet range. So that is we discuss about the network address, valid IP address and broadcast address. Let's see. First we discuss about the class A private IP address. Here is the IP range from 10.0.0.0/8 to 10.255.255.255/8. First we discuss about in detail in IPv4 bits. So it is the 32 bits, which can be divided into the 4 portions. So 32 divided by 4 is equal to 8. So each portion contains the 8 bits. Here /8. So the first 8 bits can be the network portions. Remaining 24 bits are the host portions. So that's why I have to mention the N is the network portions, then H means host portions. So that is the 8 plus 8 plus 8 equal to 24. So out of 32 bits, so 8 portions are network portions, the remaining 24 bits are host portions. Here, so in each portion contains the 8 bits. So based on the position, the radix value is changed. So 2 power 0 equal to 1, 2 power 1 equal to 2, 2 power 2 equal to 4, 2 power 3 equal to 8, 2 power 4 equal to 16, 2 power 5 equal to 32, 2 power 6 equal to 64, then 2 power 7 equal to 128. So summation of the all the bits 128. Let's take the pencil. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. You can add the all the values. So the total value is 255. So if all the binary bits are 1, the total value is 255. If it is all the binary value is 0, so the total value is 0. So it is the important calculation of the subnetting. Next, here is the example of the class A. Here, so I can explain how to calculate the decimal value based on the binary bits representation. Let's take the paint. here. So 2 power 0 equal to 1, that is the first bit portion. 2 power 1 equal to 2, 2 power 2 equal to 4, 2 power 3 equal to 8, 2 power 4 equal to 16, 2 power 5 equal to 32, 2 power 6 equal to 64, 2 power 7 equal to 128. So here is the 8 bit. So starting from 0 to 7. For example, for the decimal equivalent 10. So simply you have to calculate them manually. So 8 plus 2 equal to 10. First you have to put the number 1. So 8 into 1, 8. 2 into 1, 2. So 8 plus 2 equal to 10. So remaining bits are 0. So this is the easiest way of the calculation for the binary bit to decimal equivalent calculations. For example, 16. So 16 means, so you have to put in the 16. So remaining bits are 0. For example, 92. So 92. So how to calculate the 92? So 64 plus 36, 32 is the 96. So 64 plus 16 is the 80. 80 plus 12, 92. So 64, 0, sorry. So you can put finally in the 0. 64 plus 16, then 8, 4. So 64 plus 16, 80. So 80 plus 8, 88. Then 88 plus 4 equal to 92. So remaining bits are 0. If all the bits are 1, so the total summation value is 255. Or if all the bit value is 0, so the value is 0. So this is the honest way of the calculation, mind calculation for the subnetting purpose. Here, so here is the network portions. So it does not change. Here also, but the subnet value is /8. Here is the all the bits are 8. So this is the subnet value /8. The host portions, remaining 24 bits are host portions. So it is starting from 0 to all the bits value are 1. So 0, 1, 2, 3, 4, 5, 6, 7 up to 255. If it is 255, then again it value is incremented by another portions 1. So 1.1, 1.2, 1.3, 1.4, 1.255. It will be discussed on later video. Here, what is network address? Here, so first 8 bits are network address. Here I highlight the value. So host portion can be represented as red color. Then network portions highlighted the different color /8. So first 8 bits cannot be changed. You can see the video. So the first 8 bits are cannot be changed in the entire submask. Remaining bits are incremented. So 0, 1, 1, 0, 1, 1. Then again it can be ranged from up to broadcast address. So 0 is the equivalent of 0. For example, 1, 1. So 1, 0 means, so 1, 0 equal to 2. If it is 1, 1, the value will be 3. So it is incremented by sequentially. So the final value is the 255.255.255. So the class A IP address starting from 10.0.0.0/8 to 10.255.255.255/8. So here is the network address. So which all the bits are 0 in the host portions. Here all the bits are zeros in the host portions. Next, what is broadcast address? So broadcast address, all the bits are 1 in the host portions here. So all the bits value is 1. Then valid IP address. So the valid IP address can be used for the host machines or network devices like router, switches, or any devices. So starting from 1 to 254, because if it is all the value is 255, if it is the final value is 0 means, so 255 minus 1 is equal to 254. So this is the total estimation of the class A subnet IP ranges. Next one is the class B private IP address. So here, so class B private IP address range from 172.16.0.0 to 172.31.255.255. Here is the subnet value is /16. So /16 means, so out of 32 bits, so 16 bits are network portion, remaining 16 bits are host portions. So the first 16 bit we cannot change. Remaining 16 bits we can change based on the requirement. Here is the class B private IP address. So next one is the manual calculation for the subnet. Here 1. So here 4. So before 4 the value is, total value is 3. For example 8. So before the 8, so all the value summation is 7. So 4 plus 2 plus 1, so 7. For example 16. For example 16, before the all the values you can add, so the total value is 15. 8 plus 2, 10. So 10 plus 4 plus 1, 15. Likewise, so 32 means 31. Then 64 means 63. Then 128 means 127. So 127 plus 128. So the total value is 255. So this is the one type of formula to calculate the subnet value fastly. So you can try and again. So to calculate the subnet value for better manner. Let's come for class B private IP address. For binary to decimal calculation, 172, 16, 31, 255, then 0. So this is the decimal equivalent. This is one is the binary equivalent for the corresponding decimal value. So how to calculate the 172, 16, 31, 255, then 0. So within a short time. So 128 plus 64, that is the 192. So 128 plus 32, 160, 160 plus 12, 172. So remaining bits are 0. Likewise 16. So you can put 16 corresponding value, remaining bits are 0. Likewise already discussed. So 1, 2. So 4 means, so previously the total value is 3. Likewise 8 means 7, 16 means 15, then 31 means 31. If the all the value is 1, so the total value is 31. Remaining bits are 0. So 255. So you can put all the values 1. So 0 means, so all the bits are 0. This is the simplest way to calculate the value 0. So this way we have to calculate the binary to decimal equivalent for better calculation and manually fastly. Class B. So if all the bits value is zeros in the host portion, so that is called network address. Likewise, if all the bits value is ones in the host portion, that is called broadcast address. So here, so starting from 0 to 1, 10, 11, then 100, 101, then 110 up to 254, it is the valid IP address. 1 to 254. Then 255 is the broadcast address. So here is the total class B subnet range for the discussion. So 172.16.0.0 to 172.31.255.255. So this IP range can be used for the LAN network. Next one, class C. Likewise, class B private IP address. So the IP range can be from 192.160.0.0 to 192.160.258.258. So likewise, class B and class C are both are same for network portion and host portions. Like this also a same manner. Let's take the calculations. So here the decimal is 192, 168 and 255, then 0. So 192. So 128 plus 64 is equal to 192. So first two bits portions are 1, remaining portions are 0. Next 168. So 128 plus 64, that is the 192. So 128 plus 30, 160. 160 plus 8, 168. 1, 1, 1. Remaining portions are 0. Likewise, so 255 is the, so all the bits values are 1. If 0 means like all the bits value is 0. Here is the calculation for the binary bits to decimal equivalent. Likewise, so network portions. So the first 16 bits are network portions, remaining 16 bits are host portions. So the network portions cannot be changed, but the host portions can be varied from 0 to 254. For valid IP range, then 255 is the broadcast IP. Here, so all the bits are 0 in the host portions. So host portion means here. Network portions here. So if all the bits value is 0 in the host portion, that is called network address. So here it can be represented as 192.160.0.0/16. So it is incremented by 1 by 1. So 0 plus 1, 1, 1 plus 1, 10, 1 0 plus 1, 1 1. Likewise, it can be incremented here. Sorry. So the last IP range is 254. Then broadcast IP address range is 255. So 192.168.255.255/16. So this is the broadcast address for class C private IP address. So this is the important subnet table for the network field. Here, first column is the IPv4 bits. So that is the 32 bits. Then host portions. So how many bits in the host portions? Likewise, network portions, third column. So how many bits in the network portions? Here is the submask for the corresponding network segments. Then number of available host, that means number of IP range. Then number of usable host. So that is the valid IP address for the network devices. For example, 32. So if the two portions, let's take the paint. For example, 32. So 32 is the IPv4 bits. For example, so out of 32, so 2 portions are host portions. So remaining 30 portions are network portions. So we cannot change 30 bits. So we can only vary the 2 bits. So 2 bits means, so that is the last 2 portions. So the IP range from 00, 01, 10, 11. So that is the valid IP range is 4. So here is the 4. Then 00 is the network address, NA. Then 11 is the broadcast address. So variable IP address can be used for 0110 for the first row. Next row is the 32 minus 3. Like this. So 32. So 3. So 32 minus 3, 29. So 29 bits are network portions. So 3 bits are host portions. So here, so 2 power 3 equal to 8. So it can starting from 0 to 7. So 0 0 up to 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0. Likewise, already told. So if all the bits 0 in the host portion, that is called network address. Likewise, if all the bit value is 1 in the host portion, so that is called broadcast address. So the valid IP address range from 0 to 6. That is the valid address. So it can be used for the network portions. That is the network devices. So 0 means, so 0, 1, 2, 3, 4, 5, 6, 7. So starting from 0 to 7. So total value IP address is 8. So first 2 bits are, so first one and last one is the network address and broadcast address we cannot use. So remaining 6 bits are used for the host portions. So likewise, you can calculate 32 minus 4, 28. So 28 is the network portions, then 4 is the host portion. So 2 power 4 equal to 16. So minus 2, that is the valid IP address. Likewise, 32 minus 5, 27. So first 27 bits are network portions. So remaining 5 bits are host portions. So 2 power 5 equal to 32. So 32 minus 2, 30. Likewise, you can decrement it by 2. So network address and broadcast address we cannot use. Likewise, 32 minus 10, 22. So 2 power 10 equal to 1024. So 1024 equal to 1022. So 32 minus 16, 16. So 2 power 16 equal to 65,536. Then available host. So minus 2 is the valid IP address. So this is the subnet table for the network field. It will be helpful for the network segmentation. That is the different subnet mask can be used for the different area, production area, non-production area based on the requirement. Next. Yeah. Thank you. I hope this video is useful for you. Thanks for watching video. Click the bell button to subscribe. Let's see a next jungle video for the FLSM Class C. Thank you.